Now let's see how do we write Java code for implementing stack using an array. So we have created three classes here in stacks package. We have stack array, which takes care of implementation of stack using an array. So we will be writing push and pop operations here when we are implementing stack using an array. And then we have a stack linked list .java. So in this particular, we will be implementing operations when we are writing code for implementing stack using linked list. And then we have stack main. From here, we will be calling push and pop methods of these two particular classes. So we will see these two. First, let's see for stack array, and then we will understand how to implement linked list using stack and then see code for that. So for implementing stack using an array, we need to have several variables. So first, we need to have top. So this top, we will initialize it with -1, which means that stack is initially empty. This top almost always takes care of the topmost element, or for that matter that particular part from where the insertion and deletion has to happen. Then we have int max. So let's say we are taking it 1000. So this max again takes care of the total number of elements or maximum number of elements that can be inserted in that particular stack. If we try to insert elements more than 1000, we will get a message of stack overflow or the stack is full. And we create an array which is our stack, new int max. So the size of this particular array is going to be max. Now we have initialized all the variables. We will be putting in push method and pop method here. So let's say I have to insert 3 elements. So now let's say I have to insert 3 elements, 1, 2 and 3, and this is my top. So initially the stack is completely empty. We don't have anything. So let's start from inserting the first element or doing the push operation from here. So let's say I call push from stack main, and for calling push of stack array, we first have to create object of stack array. So let's say I create object stack array stack. Now let's call the push method, and in this push method we will also pass the variable that we have to push. So here we have to push 1. So we will push the data, we will put in the data, we'll pass the parameter that what data do I need to push. So let's say I push 1. So we are getting an error here obviously because we haven't defined this method yet. So let's go on to define this method. So we put boolean push int data. So now we have kept the return type as boolean. Why have we done that? So what we will do is we will return true if the push is possible or the push is done successfully, else we will return false. So when the false will be returned, when our stack is already full, we don't have any space. So we check that if top is equivalent to max -1, then we simply print stack is full or stack overflow, and we return false. Now how this particular thing takes care of the full stack thing? So obviously this top is the index. So it will be like if we have to insert an element here, then my top will be 0. So top is always equal to size of the array -1. So this condition makes sure that if the stack is full, then we simply return false. Now let's say the stack is not full. What do we do in that case? In that case, we simply insert the element at the top of the array. And we return. So after this particular operation, what happens is that initially my top was -1. Now when we do this plus plus top, top becomes 0, and this data is inserted at the 0th index. So at this particular place 1 is inserted. Now let's say I call this particular push method again from here. So we call stack array dot push 2. So in that case what will happen? Again this particular method will be called. Since top is not equal to -1, this particular thing will not be executed. This thing will be executed. Again, the value of top, which was 0, becomes 1. and an element is inserted at the one index. So this is 0, this is 1, and the element is inserted at this particular index. Similarly, we can just call push 3 and we can insert element. So we have seen how to do the insertion. Now one more thing, if you see here, is that here we have written the code to check that whether stack is full or not. So we can simply take out this particular code and create a method which we known as boolean is full. So what we will do is we will do this particular thing. So in this case, we check if top is equal to -1, we simply print stack is full, and rather than returning false, we return true. So we are checking that whether stack is full or not. So if stack is full, this particular condition is for stack is full, we return true, else we return false. Okay. And here what we do is we call this particular method is full. So we do if is full, then we print stack is full. If this particular thing returns true, then we print stack is full and we return false. We can remove this particular thing from here. Okay. Now let's see how do we write code for popping an element from the stack for the pop operation. So let's say I have these three elements. I want to remove 3 from the top. I simply do stack array dot pop, and I'm storing this in a element. Let's say I call this also as data, and after the pop operation happens, let's say I'm trying to print it. Okay, so obviously we will get error here because we haven't written the pop method yet. So let's go on to write the pop method. So what we do in pop is, our pop is going to be of return type int. First, we have to check whether stack is empty or not. So we check if top is less than 0, then stack is empty. So let's say print stack is empty and we return -1. And if stack is not empty, then we simply, so now let's say the top is not less than 0, which means there is some element in the pop. So what I'll do is I'll have the topmost element stored in data is equivalent to stack top. We decrease the top by 1 and we simply return this particular data. So after this particular operation, if you go on to print this particular line, the data gets printed. So then let's run this particular code to see that whether here 3 gets printed or not. So as you can see, we have element popped as 3. So we can put a space here. Now let's say I call this particular operation again. Let's see if 2 gets printed. I run this again. Okay, so we have, so now element popped is 2. So this is how we can perform the push and pop operation. And just like we have this particular method for is full, similarly we can take out this code from here and write a method boolean is empty. In this we can simply return if top is less than 0 or not. So if top is less than 0, this particular thing will return true, else it will return false. And here we call if is empty, we print stack is empty and we return -1. So this is how we implement stack using an array. Now let's go forward and see it for implementing stack using linked list.